Hello students, this is Rob from the CoAD Laser Lab, and today I wanted to make a video about the template that we use in the Laser Lab, template 3.1. And what is a template? What are they used for? Well, a template makes repetitive work easier by locking in constant parameters. Now that's a very long explanation that means nothing, but what it basically means is that this template allows you to just come into the Laser Lab and print and deals with all the machine's quirks and issues on the back end. Especially differentiating between vector and raster discrepancies. And we're going to go into that a bit more. But I'll give you an example. For the X660, our veteran machine in the corner, it just goes insane if you have different geometries with thicknesses and the wrong colors, and it just won't work. And the issue was there was no software to help you understand that difference back in the day. But now with the more updated VLS and PLS machines, we actually have a software that helps to compensate for it, but there's still some issues, so that's why we have this template. So every student in the school knows that I like to go into a bit of the history of machines, and I want you all to understand the basic underlying principles. So the universal laser machine actually runs in three modes: raster engrave, raster cutting, and vector cutting. And you're probably thinking to yourself, well, Rob, I've heard of both raster engraving and vector cutting because we use them all the time, but what's raster cutting? Well, let's go to an example. So here we have, in the proper layers, we have this vector cut, right? And we have the same file, but it has a thickness to it. Now, if you sent this to the machines, they will run them and actually cut these files. So this vector cut would take about 15 to 20 seconds. This would actually engage into a raster cut mode and would take about 5 minutes to cut. Now, it's the same exact end product, but the time differential is huge. Plus, this would actually end up looking a bit, more toasty. And if you have a site model due tomorrow and 20 sheets to cut, would you rather vector engrave in an hour, or vector cut in an hour, or raster cut in 6 hours? I mean, you could do it, but I don't think you really want to. Well, then why does that setting even exist then if we're not going to use it? Well, that actually leads more towards what this is, raster, and we're going to actually go into that in depth in another video, because I want you all to understand how you can raster to improve your architectural models. So let's go to a blank template, and I just want you to see everything that's in here. So right here is the legend, and what it actually is, it's showing you all the layers that we use in the model shop. So score is a vector cut that goes in about a quarter of the way into the material and shows a nice relief. You see them a lot in site models for topography lines. Fold. We used to have multiple folds, and it still says first fold, but what that does is it cuts into material about halfway and allows you to actually cut, or to fold your material almost origami style. And you see that a lot with Bristol boards, and it can actually work on all paper-based products, mat board, chipboards, up to a 16th inch. The 1/8 inch chipboard can fold, but what happens is you're actually piercing 2 of the 3 plies, and it doesn't work that great. You can try it, but I don't think you're going to like it. So first cut and second cut. I get a lot of questions about what is second cut. And basically, they're the same exact thing, but one goes first and one goes second. Why would you want to do that? And I'm going to show you again later on in this video, but second cut is very useful for a perimeter cut, especially if you're using a lightweight material like Bristol board. What you've seen in the laser lab is that there's a constant movement of air to pull debris and smoke away from your material and away from you. And sometimes that could shift ever so slightly. So if you're going for extreme precision, what you want to do is a perimeter cut. Skip is just something that we use internally for the template and the laser machines. First raster and second raster. Now these are new, but all machines now have these settings. And the first raster is basically a light engrave that you can just see, and then the second raster is a much deeper engrave that digs into the material. There's no depth setting. These machines aren't set up that way, but it will cut in approximately a 1/16 of an inch. And if you are using second raster, you will need to use the masking tape, the transfer tape that we have in the lab. More on that in a later video. So what we have here is the actual size of the template. Now the laser bed is 18 by 32 inches. I know you've all have gotten that number beaten into you. But what it's important to understand is this hash area in and around the template. It's a 1/4 inch offset that you should not have any file. So let's say you have this very simple, my favorite test object, a circle within a rectangle. In this location it's fine, but if you actually move it up into this bleed area, this becomes an issue with the machine. See, the machine uses this area to slow down when it's running across and cutting your file. And if you have a file in this space, you can actually hit the side of the machine and throw off the laser cutter. It'll continue cutting, but let's say it hits the machine here on this side and gets thrown off by a 1/4 of an inch. Instead of cutting the line here, it actually cuts it back here because it doesn't know. It knows how far it's traveled, and then if it hits this machine, it loses its position. So if you've got a very intricate cut and it hits the side of the machine, the rest of your cut will be completely off, and there's no way to fix it. You have to recenter, rehome the machine, and change your file up a little bit. So just please keep all your files outside of this gray hash bleed area. Okay, so let's get into an example that is very common in the laser lab. And if you're in the laser lab now, I'm going to leave a time marker so you can jump right to this. It's very common to have, especially coming in from Rhino or even Illustrator sometimes, geometry that's the wrong color. We see this and it looks blue, and everything looks like it's in the right layer. So if we just go to print, right, and we go to the laser cutter, most of you will get an error that looks like this. It's basically saying, Rob, there's no settings that we can see. There's no proper raster, there's no proper vector. Sorry for the motorcycle outside, I have a enthusiastic neighbor. And why is that? Well, if we look at the actual layer properties, this is very common, especially from Rhino. It comes in, and what you told Rhino was blue. Rhino defaulted blue as color 160, which is blue, but it's not machine blue, if you understand. AutoCAD actually has a long history with getting Microsoft colors locked in. So if we go to this color palette, you'll see down here there's like the basic colors. So when it says you need blue, oh, that's blue versus the 160 or 180 that it was previously. So how do we fix this? Well, this is actually where the template comes in incredibly useful. Actually, before we get into that, there's another issue that sometimes happens if you had done your project in Illustrator. The lines will actually come in with the set line thickness. So this looks like a regular 0 thickness line to us humans, but to the machine, it's actually 1.06 millimeters. So this would, especially on the white machine, not cut properly. The ULS program for the newer machines would compensate for this, but just in case, we're going to learn how to fix that. But to show you, we can type in the color LW display, the command LW display, and turn it on, and you would see, oh wow, that actually has quite a thickness to it. So this is the power of the template and the power of AutoCAD, why we use AutoCAD in the shop. Match properties. It is the greatest command in AutoCAD, in my opinion, and Rhino and Illustrator, as far as I know, and you can come up and tell me that I'm completely wrong, just does not have. So what we're going to do is we're going to come here and we're going to click on the layer we need to change it to. So first cut. Alright, so now you see the icon is slightly changed to another paintbrush. That's telling us, oh, I've loaded the properties of first cut. Anything I touch now, and this is going to be a great example, will change to that. So that has now become cut 1 with all the proper layers. So we're going to do that here. We're just going to keep clicking on everything. Okay. So now if we click on the geometry, you see it says cut 1, and even all the properties have changed to what we need. And we're going to do it again with our fold. We come here and get our fold. Okay. Now we're going to come up here and we're going to get score. And we're going to come and click. What I'm doing is what's called the bounding box, so the all-inclusive. In AutoCAD, if you click and you go to the right, even the tiniest bit it touches will turn to what you need, so like that, versus if you did a bounding box to the left, you need to select the entirety of it. So you see how the blue is still blue, but if you come up here, once you pass the and encompass the entire object, that's where it would actually change it. So that's a way of the differentiation between left bounding box and right bounding box in AutoCAD. See, you're going to become an AutoCAD master by the time you're done at NJIT with me. Okay, so now this is all set, so we're going to go up to print again. Laser cutter. Do a quick preview. And we're going to plot. And see no error message now. We'll go over to the ULS, and there it is. So you see how that actually took a little bit of selection. What we can do is we can use the power of AutoCAD and layering to actually speed this up, which is going to be useful if you have like 20 or 30 sheets. So AutoCAD and layering, right? We have all these layers. It says cut from our Rhino file. It says, you know, folding and mark. What we can do is we can actually we'll set ourselves to the 0 layer. We can lock the skip and null layer so it doesn't get in our way, and we can start selecting. So there's a couple ways we can do. We can select something and hit select similar. That'll grab all the polylines because that's what we had selected previously. Obviously it doesn't grab everything, so you'd have to come and grab the circle, select similar, if I can read. There we go. Okay, and then these are lines, so we'll select that and select similar. Now if you had 30 sheets of this, doing this command would actually select all of them across the board. And you can come over to the properties window and set it to cut 0, 1. Line weight, you know, just make sure that's set by layer. So now we've just fixed all of that without using the match properties command, right? This is different ways of doing it. So we can come and select folding, and we can select it to fold 0, 1, and the same with the score, right? So that's another way to do it. Now, if you have even more files, more sheets in this file, what we can do is, I was showing you a little bit earlier, we can lock these layers, right? Skip and null, we can lock. We know everything in this is on a mark or a folding layer, so we could turn that off. We could just grab the entire sheet, like you could just go like that, right? And select everything to cut 0, 1, and it's going to give you this whole, you know, error message. Hey, some of these aren't going to be changing, and that's fine because they're on a lock layer. It doesn't matter. So we just changed everything. You see how it deselected everything that was locked? So we can change all of that to the cut 0, 1. So then what we'll go now is we're going to lock cut 0, 1. We're going to turn on folding, or unlock folding, I should say. Set it to fold, right? And there it is. And we'll lock folding. We'll turn on mark. And we'll set this to score. And there it is. So that's 3 different ways in which you can use the template to fix your geometry very quickly. I think it's really important to point out, though, that the current template when this video is being made is 3.1. Previous templates do not have the legend set up properly. It's all, for whatever reason, set to a skip layer. So if you need a new template, I will leave a link down in the description. I hope this has been educational for you. If you still have questions, please always email me at ra95@njit.edu or come up to the Laser Lab, and I will answer all your questions. All right, have a good day, and happy laser cutting.